Okay, we're going to continue on with our thermodynamic study by uh, uh, talking about heat transfer. This is chapter 16 of conceptual physics. Let me dismiss my image here so it doesn't interfere with the presentation. So, uh, heat transfer. We're going to talk about heat transfer on three mechanisms: conduction, convection, and radiation. And we're also going to discuss the Newton's law of cooling, global warming, and greenhouse effect. And we're also going to talk about solar energy. Um, so heat transfers energy from hotter objects to cooler objects in three different ways: conduction, convection, and radiation. We learned from our last chapter that heat transfers always from high temperature objects to low temperature objects. Uh, if you think about, you pour ice into a glass of hot tea, it's the ice isn't cooling down the water. The hot water or the hot tea is melting the ice. It's going from the higher temperature object to the colder temperature object. So the hot tea or room temperature tea, if it happens to be, is cool is melting the ice. It's putting the heat energy into the ice and melting it. Okay, so conduction. Conduction is the transfer of internal energy by electron and molecular collisions with a substance, especially a solid. And they're showing two solids here. One is like a tile floor, and one is wood. And why you can see the foot on the tile floor is shaking because it's cold because the tile it conducts thermal energy better than the wood does. Wood is an insulator, tile is a conductor. So, uh, we're discussing conduction, and so tile is a better conductor of heat energy than wood. Good conductors conduct heat quickly. Substances with loosely held electrons transfer energy quickly to other electrons throughout the solid. Examples are silver, copper, gold, and other metals. Those three that I just mentioned, silver is the best, then copper, then gold. Those are the most thermally conductive materials. And then you have, aluminum and steel, and they're further down there. But most metals, can't think of an exception, are good thermal conductors because they're also happen to be good electrical conductors. Okay, poor conductors are called insulators. Molecules with tightly held electrons in a substance vibrate in place and transfer energy slowly. These are good insulators and poor conductors. Uh, Examples are glass, wool, wood, paper, cork, plastic, foam, and air. Um, if you have some oven mitts at home, some of the newer ones have like a silicone, um, uh, silicone. It's like a silicone glove. The older type have very thick fabric. Um, Substances that trap air are good insulators. Examples: wood, fur, feathers, and snow. That would go into the cloth, the thick cloth oven mitts. Uh, they trap air, so they're good. They're good insulators. Okay. If you hold one end of a metal bar against a piece of ice, the end of your hand will soon become cold. Um, does cold flow from the ice to your hand? Well, we just mentioned that transfer goes from a high temperature material to a low temperature. So it's actually your hand that is uh, transferring your heat to the ice. So no, cold does not flow from the ice to your hand. Heat flows from your hand to the metal and from the metal into the ice. The metal feels cold to your touch because heat is transferring from your hand into the metal. Okay, insulation. Insulation doesn't prevent the flow of internal energy. It slows the rate at which internal energy flows. If, I have a thermos. If I pack it full of ice, it can stay cold. I have a real good Starbucks thermos that uh, I use, and when I would pack it with ice and put the cap on, it could there would be ice in it till the following day. But if I left it there for a week, it would just turn it, room temperature water. So it doesn't prevent the flow of internal energy. It slows it. An example, rock wool or fiberglass between walls slows the transfer of internal energy from a warm house to a cool exterior in winter, and the reverse in summer. So you can't stop the flow of energy, but you can slow it. You can slow it down. Okay, a dramatic example is the snow patterns on the roof of a house show areas of conduction and insulation. Bare patches show where heat from the inside has leaked through the roof and melted the snow. So you can see that where you see the roof here, that it's leaking warm air from the roof. Uh, okay, and that's the end of the conduction section. The next section will be convection.